Hello, third graders from Knollwood Elementary School. My name is Nick Weisenberger from Coaster101.com, and I think it's so awesome to hear that you guys are learning about force and motion and how that applies to roller coasters. You submitted some pretty good questions. I'm going to try my best to answer them. Alright, so your first question is, why do we need balanced and unbalanced forces? Well, first of all, what is a force? A force is basically a push or pull on an object. The force of gravity wants to pull objects towards the center of the Earth, for example. If there are two forces acting on an object and they are equal and opposite, this is called a balanced force and the object will stay where it is. Unbalanced forces always cause a change in motion. They can make objects begin to move, speed up, slow down, or change direction. Therefore, a roller coaster would never roll down the track without unbalanced forces. The next question is, how do you know the speed a roller coaster will go? Well, roller coasters are all about kinetic energy, the energy of movement, versus potential energy, the energy of position. The top speed of a coaster is usually achieved by being lifted to the highest point and then released, or it might use a launch system. In either method though, the stored potential energy is converted to active kinetic energy. If we don't take friction into account, and we know the height of the tallest hill, we can calculate the speed using the equation velocity equals the square root of 2 times the height times the force of gravity. For example, we know the height of Fury 325 is 325 feet, so we can plug the numbers into the equation and we estimate the top speed is going to be 98 miles per hour. Now in reality, a small amount of energy is going to be lost due to friction. The actual top speed of Fury 325 is listed as 95 miles per hour. The next questions are, how does a roller coaster keep going and how does friction stop the roller coaster? And also related, what materials do you need to make a roller coaster go fast? So friction is the force that resists motion. If there were no friction, there would be no energy loss and the roller coaster could keep going and going without stopping. So unless you want to ride the roller coaster forever, having some friction is a good thing. One thing that real roller coaster engineers have to consider is rolling resistance or rolling friction. Any coasting wheel vehicle will gradually slow down due to friction, but some vehicles will slow down faster than others depending on the materials. For example, a steam train which has steel wheels running on steel rails has low rolling resistance, so it will roll a lot further than say your school bus of the same mass that has rubber tires and is driving on a road. There's more friction there. So roller coaster engineers must carefully choose the materials the wheels are made out of. A harder material like nylon has lower friction but could result in a bumpier ride, while soft wheel material like polyurethane has higher friction but could result in a smoother ride. And there's other factors like durability and endurance of the wheel as well. So roller coaster engineers really need to find the right balance between all those factors. Another great question that you asked is, how do you know if a roller coaster is safe to ride? Safety is the #1 priority of roller coaster designers. Before the roller coaster is built, all of the g-forces acting on the rider are calculated on a computer. Once the roller coaster is built, the g-forces can be tested with an accelerometer, which are used to measure the force that your body is experiencing during the ride. So as long as the forces are below the safety standard limits, then the roller coaster is safe to ride. And nowadays you can even get accelerometer apps on your phone and measure some of the g-forces yourself. Another good question is, when you are on a roller coaster, how does it not roll off the track? Well, there are kind of two parts to this answer. One is the forces acting on the cars, and the second is the way the cars are designed with the wheels. Here's a little experiment to show you how a roller coaster doesn't fall off the track, using my very scientific and awesome Spider-Man bucket. So if we take a basketball and put it inside the bucket, and we turn the bucket upside down, the ball falls out because of gravity, right? So, if we put the ball in the bucket though, and we spin the bucket, the ball stays in and doesn't fall out because of centripetal acceleration and the forces acting on the ball. So what's going on here? Is it magic that's keeping the ball in the bucket? No, this is an example of centripetal force, which is when an inward force acts on a circular moving object. So the ball is falling at the same speed as the bucket, so the ball doesn't appear to fall out of the bucket. But if we were to remove the bucket or slow down at the top of the spin, the top of the circle, the ball would fall out because the forces are no longer balanced, going back to balanced and unbalanced forces. Centripetal acceleration points towards the center of the circular path of the train, but is felt by passengers as a force pushing them to the outer edge of the circular path. If a roller coaster were to slow down for some reason at the top of a loop, well, that's why they have wheels on the underside of the car to keep the trains onto the track. If the roller coaster were to lose momentum, there are three types of wheels that secure the vehicle to the track. The road wheels are the wheels that are on top of the rails and they support the weight of the car. You have side friction wheels on either side of the car, or also called guide wheels. And then you also have the upstop wheels, which are underside of the rails, which help prevent you coming off the track. So even if the roller coaster were to lose momentum in a loop, all the sets of wheels would prevent the car from falling off. Thanks again for sending your questions. Hopefully I answered a few of them today. Good luck in school, and if you want to learn more about roller coasters, check out Coaster101.com. Bye!